In this example, we have a walnut grower who wants to maximize his total yield in terms of the number of trees that he plants per acre. So let's have our variable x be the number of trees that he's going to plant per acre. Then we need to find an equation for total yield. Total yield will be the average number of pounds per tree multiplied by the number of trees on that acre. To figure out the average number of pounds per tree, notice that we start with a baseline of 60 pounds, but we lose 2 pounds for every tree over 20. That gives us this little equation, 60 minus 2 times x minus 20. The number of trees per acre is just x. So that means that our total yield becomes negative 2x squared plus 100x when we multiply those two expressions together. Now, our goal is to maximize total yield, so we're going to start by finding the critical numbers, which means we need to find the derivative. The derivative is going to be negative 4x plus 100. We set that equal to 0, and we find that x equals 25 when the derivative is 0. Now we check that number in the second derivative. The second derivative is negative 4, which is always negative, which means that 25 gives us the absolute maximum of our yield function. So the farmer should plant 25 trees per acre in order to maximize yield. To figure out what the maximum yield is, we plug 25 back into the original yield equation and find that maximum yield is 1,250 pounds. For our second example, we've got a comic book maker who wants to minimize costs in terms of the number of books per print run. So let's have our variable x be the number of books per run. Then the total cost is the cost of storing those books plus the cost for setting up the print run. We're going to work on each of these separately. Let's start with working on the cost of storage. We're told that demand is uniform, which means that we get to assume that on an average day, half the books from the previous run are still in storage. That's because the number of books decreases linearly from x, the number of books from the previous run, to 0 when they're all sold out. That means that on average, half the books from the previous run are in storage. So the total cost for a year of storage then is 50 cents multiplied by the number of books, which is half the number of books from the previous run. So 50 cents times 1/2 x, or 0.25x. Now that we have an expression for the cost of storage, we need to find an expression for the cost of setup so that we can find an equation for total cost. Now, it costs $200 to set up one print run. So let's have y be the number of print runs. Then the cost of setup is just 200 times y. However, we don't want a y in our equation, we want x's. So we need to find a way to relate x and y. We need to produce a total of 20,000 comic books. If we make x books per runs and we make y runs, that means x times y needs to equal 20,000. Now turn that around, solve for y, and y equals 20,000 divided by x. That is, the number of runs that we do is 20,000 divided by how many books we do per run. So the total setup costs then are $200 multiplied by the number of runs, or 200 times 20,000 over x, for a total of 4 million over x. Now we've got a formula for total cost. Total cost is 0.25x, that was the cost of storage, plus 4 million over x, that was the cost of setup, and x is the number of comic books produced per run. We are now ready to minimize this function by finding the critical numbers. That means that we need to start by finding the derivative. The derivative will be 0.25 minus 4 million x to the minus 2. Set that equal to 0 and solve. And when we solve that little equation, we will find that x is plus or minus 4,000. Of course, we can't print negative 4,000 comic books per run, so our only critical number is 4,000. Now we're going to check that in the second derivative, means we have to find the second derivative. The second derivative will turn out to be 8 million x to the minus 3. Plug in 4,000 and we get a positive number out, which tells us that 4,000 gives us the absolute minimum cost. So they need to run 4,000 books at a time in order to minimize their total costs.